Hello friends, my name is Vivek Sharma. Today we can cover this interesting problem that's called 0 1 matrix. So in this problem we have been given a matrix that consists of 0 and 1, and we need to find the distance of the nearest 0 for each cell, right? And the distance between two adjacent cells is 1, right? So what I did, I copied this diagram here. Let's also see the node section is just a limitation, like the number of elements will not exceed 10,000. There are at least 10 cells are adjacent in only 4 directions, so we can move only up, down, left and right. All right, so let's try to understand from this diagram. Okay, so when we say the distance from nearest 0, what does that mean? Distance from the nearest 0 cell will be like if we need to pick any non-zero cell, and we need to calculate the distance from the nearest 0 cell with respect to non-zero cell, right? So that what this is what it means, right? Because 0 cells are already there, right? So we need to calculate the nearest 0 cell distance. So what is the distance of this one with respect to other 0, right? So what is the nearest 0? So nearest 0 is this one, this one, this one and this one, if we check all the 4 directions, right? So we need to check all the 4 directions, right? Up, down, left, right? So uh, in this particular example, the output would be the same as the input. Now let's see this example as well. What is the distance of this cell from other zeros, right? So this will also be 1, right? What is the distance of this cell? This is having like this 0 on top of this, so this will also be 1. This is also will be 1 because there is another 0 here, right? What about this one? So this one, basically this 0 is there, but we cannot go diagonally is not allowed, so we need to go either this way and this way. So we need to calculate two distance, right? So basically, remember, the problem is saying like the distance between two adjacent cell is 1, right? So between two adjacent cell the distance is 1, right? So if we calculate like if we will measure the distance, like this is one distance and this is another distance, so total distance will be 2, so we need to update this as a 2. And let's say if we choose this path, if we will go left side, and then if we will go like this path, and then we are considering this 0, then also it will be 2. Or let's say we are going up and then we are going left, then also it will be 2. Or we can go up and then we can go right. So these are like couple of options to update this cell, but ultimately the distance will still be 2 no matter what option we choose, right? So this is like the problem here. All right, so these are the two examples, and now we know like this is how we need to calculate the distance as well. And let's say like hypothetically, if I am having other 1 1 1 here as well, right? So just to little bit make it little bit more interesting, so let's say this is 2 and this is 1 and this is 1. Now what will be the distance of this one from the 0, right? So the minimum distance of this one will be, it needs to go this way and then this way, so this 0, right? So this will also be 2, right? What about this one? This will also be 2 because we need to go in the above direction, right? What about this one, right? So this one basically, either we can go this way and then this way or this way, right? Or we can go this way and then this way and then this way. No matter which way we choose, it will still be 3, right? Because one distance is this 2 and then 3, right? Or 1 2 3, or basically 1 2 3, or basically 1 2 3. So this distance will be 3. So this is like one hypothetical example I made just to understand this problem little bit better way. All right, so now what are our observations first of all, by walking through this problem, right? So at every step we are just checking this non-zero cell, and then we are just checking the neighbor like up, down, left and right. And if we find any zero cell, then we are incrementing that value. That's what we are observing here. And whenever we encounter this kind of a pattern that we are choosing one cell and then we are going, we are just checking all the neighbors and then we are moving one step forward and then we are checking all the neighbors again, then that's a strategy that's we call BFS, right? BFS means breadth first search. So this is like breadth first search strategy. Okay, very good. So now we found the pattern, and now we need to take the queue as well, because BFS we solve the problem with the queue. So now let's see that how we are going to solve this problem. All right. Another thing is basically we can just check, not check, but we need to store the location or indices of the matrix, right? And we always store the location or indices itself, right? Why we do that? So that we can just go to that particular location and retrieve the related data or the stored data to that location. So it is always a good idea to store the indices in the queue, but not the actual data, because actual data, see here, this is like actual data. If you will see here, this is like all the duplicate data, so it does not make sense. We cannot uniquely identify, but if we store the address or the location, then we can it's like uniquely we can identify the data, and then we can retrieve from that location. Anyways, so this matrix basically I'm just storing the location. In fact, I'm not storing, but I'm just making these locations so that we can just store these locations to this queue. And this is like for understanding, so don't, let's not get confused with the coding part. We are not going to make another matrix or anything. We are using these coordinates in the xy format while doing the coding, but this is what I just made these locations so that I can simplify the concept. Like this is how we are going to understand the problem. All right, so let's do this. Our approach will be, we will be storing all the zeros, right? And from those zeros, once we store all the zeros, we will poll the zeros one by one, and we will check if there is any neighbor that is 1. If it is 1, then we are going to update that value uh, with the distance, correct distance, right? So that is our approach. Now let's go ahead and do that, right? So first is this 0. So what we will doing, we will be storing this corresponding location. And another thing we can do, we can mark it as a visited, or let's say just cross this, not cross but make it circle. Now let's go ahead and store this 2. 2 means this second location, but this 0, right? And then let's go ahead and store all the 0th location. Okay, so this is 5th, and this is 6th. In fact, not 5th, but this is 4th. Okay, so 5th we are skipping because 5th is in the middle and 5th is this location, right? So we are skipping this because we are storing only the zeros location, right? And then similarly 7, 8 and 9. All right, so now we have all the locations here. Now what we will do, we will mark all these zeros as a visited. Now we will poll from the queue one by one. So let's go ahead and poll this guy, right, from the queue, and just check all the neighbors. So if you will check like right side 0, downside is 0, and they are already visited as well, so we are not going to do anything, right? Similarly, just poll 2. So 2 is basically this 0. Again check neighbors, right side, left side, they are already visited and also 0, so we are not going to do anything. But if we go downside, this guy is 1, right? So we want to store that in the queue, and that location is 5th location, right? So we will be storing to our queue as a 5th location here. And another thing what we need to do, we need to update this location, right? So you may ask the question, okay, it is already 1, why we are updating? So remember one point, like we need to build the algorithm, right? So even if we don't update the location at this particular example, this is going to work fine. But what about this example? So we need to apply some logic that will be generic for all the test cases, or or I mean for all the examples or all the data use cases, right? So that's why we are going to update this. And how we are going to update, we are going to update this location, this particular location, 5th location, with basically polling this data 2, right, and then +1, right? So whatever at the 2 second location means this 0 and then +1. So this will be overwriting with 1. I mean 1 we will be overwriting with 1 to build the logic, right? Because we need some generic logic to so that it can apply it for all the test cases, right? So that's what we need to do. All right, let's do the same mechanisms for all the uh, elements, right? So for the third, I will do this one more. So third we will poll and we will check, okay, this is 0, we are not going to do anything, this is already visited. So again quickly 4, 4 is basically we are not going to do anything on the right side and the downside because this is already be updated. Remember, like we already mark it as a visited and we already stored that in the queue on the, like in the end in the queue, right? So we already inserted in the queue, we mark it as a visited as well, so that we are not going to visit it again. And I did not mention this thing, but it's understood, like whenever we are doing any breadth first search or depth first search, we are marking every, whenever we are visiting any cell or any item, we are marking it as a visited, so that we can make sure that we are visiting that cell or data only once, right? So we don't want to repeat the same process with same data again and again. We don't want to visit it again and again. So that's why we need to mark it as a visited. We will see whenever we will write the code. All right, similarly sixth. So what is sixth? Sixth is this location. We will check the same thing. Okay, it is visited, this is visited, and this is visited. We are not going to do anything. Similarly 7, 8, 9, and 5. 7, 8, 9, and 5. We will poll and then we will say okay, it's done, right? So that's how we will do that. Now let's quickly do the same thing with this example as well. Okay, very quick, and then we will jump to the code. Okay, so this is our queue. Okay, and similarly, basically, if we will quickly do this thing, 1 2 3 4, oops, what is that? 1 2 3 4 5 6 7 8 9. Okay, so quickly store all these zero, right? Zeroth location, 1 2 3. So 1 2 3 4 6 4 6. Remember, this is 5, so we are not going to store 5. And then so these are all the zeros. Now let's poll this guy. So poll this guy and check the neighbors, right? This neighbor and this neighbor, they are already visited and they are already 0, so we are not going to do anything. Now let's poll 2. So 2 is this guy, left is already visited, right is already visited, downside is not visited, and that's the location of 5. So we will be inserting this location to the queue and we will mark it as a visited as well. Okay, and we will be updating this location as well. So what we will be visiting, I mean whatever the data on the second location, and then +1 as well. So we will be basically ideally this will be like data at the second location and then +1, right? So this bracket is basically whatever the data or the second location and then +1. Okay, we will see more whenever we will write the code, but it's fine now. So now let's go ahead and poll 3. So what is 3? 3 is this guy. Let's mark, let's poll that, right? So whenever we will be inserting to the queue, we will be marking them as a visited, but once we are polling, we are checking the neighbors. So let's check the neighbors. Downside is already 0, it's already visited, so we are not going to do anything. Left side is already visited, we are not going to do anything. Let's quickly poll 4 as well. Fourth location means this 0. And right side, we remember, like we already updated this cell and we already inserted q at the 5th location here, and we already marked it as visited, but downside we did not visit. So let's go ahead and do the insertion here. So that is the 7th location, right? So we will be inserting the 7th location into the queue and we will be marking it as a visited as well, right? Now what is next in our queue? That is 6th location. So 6th location is this guy and 6th is this guy, right? So now just check left side. Left side is already visited, downside that's not visited, so let's go ahead and that insert to the queue as well, and that is at the 9th location. So we will be inserting the 9th to the queue. All right, now what's next? Next is 5th, right? So 5th is basically we will be polling this guy and we will be checking, okay, left, right, and there is nothing, right? And then downside, it's not visited, so we'll mark it as a visited, insert it in the queue, and that is 8th location. And also whenever we are seeing non-zero item, we are updating that value as well. So we are coming from basically 5th location. So what is at the 5th location? That is 1, and then we will be updating this location as a 1 plus 1, so we will be updating it as a 2. Remember, other locations we will be updating with the 1. So 0 plus 1 1. This is also, it's coming from upside, so we will be updating 0 plus 1 1. And this location also we are updating with corresponding to 0 plus 1 plus 1. 0 plus 1 equals to 1, right? So that's how we did. Now seventh location we will be polling this guy, and now we don't have to do anything because this right side, this 2 is also visited and we already inserted in the queue in the previous step. Similarly for 9 and 8 we will be doing the same thing. So 9 is this guy and then we are polling the ninth, and then we will be polling 8th as well, but there is no neighbors uh, there is no neighbor that did not visit, right? We already visited all the neighbors, so it's fine until the time we already visited this matrix. So uh, let's do this. Let's write some code and let's try to understand this from there. Okay, so first step is basically if base case will be the like matrix, if it is matrix is null, right? So if matrix is null and then length is 0, then we are not going to do anything, we are just returning the empty matrix. Now let's take two variables here, and that is matrix m and n means row and column here, and remember what we see here, we are taking the queue and we are storing all the zeros and we are marking them as a visited. So we are going to do the same thing here as well, right? So let's go ahead and do that. Queue new linked list boolean visited. Why visited? Because we want to make sure that we are not visiting one cell again and again, right? So sorry for typo, let me correct that. M and N, and let's correct the typo. So this is boolean. All right, let's do this looping. I equals to 0, I is less than m, I plus plus, and nested loop here. Integer j equals to 0, j is less than n, and j plus plus, and we need to check like if this matrix ij equals 0, right? Then let's go ahead and store these coordinates I comma j. So remember what we were doing here, for the simplicity we were taking 1 2 3 4 5 6, like, right? This just to understand this problem, but in actual we need to store the coordinates in x and y pair. So that's how exactly we are doing. Now let's go ahead and mark them as a visited as well. So I comma j equals to true. So whenever we are inserting all these locations here into the queue, we are marking them as a visited so that we can make sure that we are picking the right cell and we are not visiting the same cell again and again, right? So now let's define directions as well, because we need to traverse to the 4 directions. So 0 1 0 1, oops, and 0 minus 1. These are like 4 directions. We need to move to the 4 direction. 1 0 minus 1 0. Hope this is clear, right? So 0 1, like this is the 0 point, right? And if we have to move like 0 1, right? 0 means like x coordinate and 1 is the like the y coordinate, right? So 0 is the x coordinate and y is the 1 coordinate. 0 1, or we need to go 1 0. 1 means like 1 comma 0. 1 will be like x coordinate. So in fact this will be like 1 0, right? 1 0 x coordinate. So x coordinate we will be moving here, and 0 1. So x coordinate will be 0 and y coordinate will be 1. Similarly minus 1 0, and then 0 minus 1, right? So that's what the directions I'm using in the code here. Okay, now simply do the breadth first search technique here. So what we do in the breadth first search, we check if queue is not empty, then let's go ahead and take the size of the queue, because that's how we need to iterate the queue, right? So int size equals to queue dot size, and then another for loop integer I equals to 0, I is less than size, I plus plus. Why we do that? So remember here, whenever 1 is there, then we have to iterate only one time. Whenever all these values, like whatever the size of the queue, that's many numbers we need to iterate, right? So that's the size of the queue. So that's the number that we need to iterate all the elements present in the queue. So that's why we are taking the size. Now let's poll this array from queue. Current x is current 0, int current by equals to current 1. Why we are taking this? So this, remember, these are the coordinates. So current x means current y means these are the locations. This is nothing but this is the location that we are pulling from the queue. The only difference is here I am taking the numbers and here I am taking the coordinates. So the only difference is this is like this is like one dimensional array, x and y coordinates, and here it is simple number. That's the only difference. Otherwise the same approach, same thing, whatever we discussed here. So now we need to move to the 4 directions. How we are moving to the 4 directions? With the help of these directions, right? So let's go ahead and move all the 4 directions. And what is our new x coordinate? Will be current x plus direction 0. So 0 is basically this guy, right? So the first is x coordinate and second is y coordinate. So we are adding first direction 0. So here first of all this directions is 2-dimensional array, and we are taking this first dimensional array in each iteration, and 0th is the x and 1th is y. So that's how we are adding, and we are moving to the all the 4 directions, right? So current y plus direction 1. All right, good. Now let's go ahead and check for the base condition as well. Means it should not cross the boundary, right? So let's go ahead and do that. Y equal to 0, y should not be greater than 0, and y should not be greater than n minus 1, and it should not be visited as well, right? Because it does not make sense to visit the same cell again and again. If it is 0, then we don't want to visit 0 again. We want to visit like non-zero cells, right? So we want to visit like whatever non so see here, whatever the non-zero. So in this example is non-zero is 1, and in this example non-zero is this one, and then other 3 ones, right? So we want to make sure that, and if it is like if it is going out of boundary and if it is already visited, then let's go ahead and don't do anything and then find the next direction. And if x and y everything is valid, and if it is not visited, then what we do, we will be offering, means we will be inserting those x and y coordinate into the queue. And that's what we did, right? That's what we did in our whiteboard as well, right? So that's what we did here while drawing run. So we were inserting to the queue for the new x and y, right? Or this is like a little bit so if I, okay, nice. So this is the matrix. Okay, so here basically this is like 1, right? That's what we need to do. And if I copy this matrix as well, and in this example basically these ones, they are not visited, so we need to now poll this 0, and we need to check all the neighbors, whatever we did in our previous try run, right? All right, so come here and inserted those locations to the queue, and then mark them as a visited as well, x by, right? And then another thing is basically what we need to do, we need to matrix matrix so whenever we are, this is a little messed up, so let's see here. Whenever we are coming basically from this direction, right? Whenever we are coming from this cell, we are updating this cell with this cell plus 1, right? So and in this cell, if we are coming from this cell, then we are updating this cell as a 2, because 1 plus 1, it is coming from this cell, right? So it is coming from this cell, then we are updating this as a, we are just incrementing by 1, right? And similarly this one, basically if it is coming from top side, from the above side, then we are updating this 0 plus 1 is 1. That's what we are doing, and that's what exactly we need to do here as well. So current x and then current y and then plus 1. So what is current x, current y? Current x, current y is basically this one. Current x, current y is the location that we pulled from the queue. right? And then we are moving the basically 4 directions. So let's say we polled like second location. So second location was this guy, right? And then we found another location that is fifth by going all these directions, up, down, left, right. So we inserted that to the queue. We marked them as a visited as well, and we incremented that row as well. So what we incremented the fifth location is whatever the data at the second location and then +1. That's what exactly we are doing here. So hope this is clear, and then we are done actually. So return matrix. Let's quickly check for the compilation error. Okay, so boolean I forgot or missed here the semicolon. Let's see, current by. Okay, there is another typo here. Let's see here. So this example is working fine. Let's quickly check the, let's quickly change the example, right, for the second case. So looks like this is also working fine. So time complexity wise, basically this will be m into n. TC here is the time complexity, and space complexity will also be m into n. So m is the matrix row, matrix length, and n is basically the column length, right? So if the matrix size is m into n, then basically time complexity we are traversing basically m into n times here, right? M into n times, and also we are maintaining like the queue itself, right? M into n. So in this process also we are basically doing the same complexity m into n, and space complexity is m into n. So let's quickly go ahead and submit, and let's see if it is working. So looks like this concept is working, and it's working fine conceptually, right? So let's very quick summary before ending this video. So this is like binary matrix. We have been given 0 and 1 matrix, and we need to find the distance of the nearest 0 cell. So first of all, the first question we should ask, what does that mean, right? So what is the nearest 0 cell means? It means we need to pick non-zero element here. So non-zero element in this case is basically 1 that we need to pick, and we need to check like all the 4 direction that what is the 0, like what is the nearest 0 cell, and we need to update this non-zero cell, right? That's what we need to do. So implementation wise, what we are going to do, we are adding all these zeros to the queue, all the zeros location in the to the queue, and then we are polling this 0 one by one, and we are checking all the 4 directions, and then we, if we find any one or non-zero cell, then we are updating that cell by incrementing by 1. When I say incrementing by 1, what does that mean? If we are coming from this cell to this cell means this 0 cell to the 1 cell, then we are updating this 1 by basically by adding the 1 to this data. 0 plus 1 is 1. And let's say for example, if we are coming to this cell from top, and then this value is already 1, then we are updating this as a 2, because 1 plus 1 is 2. So from where it is, wherever it is coming, we are incrementing 1 to that particular data, and that's what exactly we are doing. So current text is basically from where we are coming, we are polling from the queue, and this is new x and y coordinates, right? And this is the new x and y coordinates, and we are checking, okay, my neighbors are already visited or not. If it is already visited, I am not doing anything, I am skipping here, I am doing the continue. And if it is not visited, then basically I am checking, okay, from where it is coming, and where from wherever it is coming, I picking that data and then incrementing by 1 and storing to the right spot. Right spot means the spot that not that's already not visited, right? So that's the location that I am updating. So in this case, like for example, I'm updating this as a 2 because it was not visited earlier. So I'm coming from here, then I'm picking this data and then incrementing by 1, and I am updating this and then inserting to the queue and marking that as a visited as well. So here, right, so I'm incrementing by 1, right, and then inserting to the queue and visited. So then it will be serving the neighbor cell for the next iteration. So that's what it's doing. It was a little lengthy video to explain all this thing, but I think it might be helpful. Thanks a lot. Have a good one. Bye.